Welcome everyone. In this video lecture, we will solve a GATE 1997 question which is based on the admittance matrix, or we can say the Y parameter calculation in a two-port network. So in this question, a two-port network is given, okay, which is shown here. So we have to find the admittance matrix and the corresponding options are given A, B, C, and D. So we have to find which one is correct. So this one is the two-port network and it is given admittance matrix. So we have to know the admittance matrix is nothing but simply our Y parameter. So I am just writing Y parameter and admittance matrix, both are same, admittance matrix. Okay. So for the Y parameter, we have to know the relationship which is our I1, I2. This one is very important. I1, I2. Then we can write as Y by Y11, Y12, Y21, then Y22. Okay. And it should be our B1, B2. So this one is the important parameter. Then we have to find the Y1, Y12, Y21, Y22. Okay. So this one is the circuit. Okay, so what I am doing, I am making this one as a ground, so checking this one is a ground potential. So what we can do at this point, say this point is our A and this point is our B. So in this case, the three current we can say entering at point A. So say this current is nothing but simply our I dash, and this current is our I double dash. Okay, so if we apply KVL, if we apply, sorry, KCL, not KVL, KCL at point A. So at point A, there are three currents are coming. Say this one is our I1, and this I am saying I double dash, and this current I am saying I dash. Okay, better to write one, so it will this symbol right I dash 1. Why? Because I1, then it should be I1 dash, and I1 double dash it is coming here. We are just assuming. Okay, so now we have to write the KCL equation. So one can write I1 plus I1 dash total incoming current at point A, I1 plus I1 double dash equals to I1 dash total incoming equals to total outgoing. Now what we can write, I1 write as it is, I1 plus I1 dash, I1 dash, I1 double dash, sorry, I1 double dash. For this picture, what I am doing, this one is 10 ohm resistance. So the potential at this point A will be our simply V1, and this potential will be simply V2. Is it okay or no? And this current I am saying this one is our I1 double dash. Okay, so current is going in that direction. So I1 double dash is nothing but simply higher potential, that is a V2 minus V1 by 10. Simple. Okay, so one can write this as a V2 minus V1 by 10. Okay, because this one is V2 potential, V1 potential, this one is ground. We are taking this as a reference, 0, V2 minus V1 by 10, and I1 dash. I1 dash is nothing but simply this current. Okay, this one is our I1 dash. Okay, and 10 ohm resistance is there, and this voltage is our nothing but simply V1, and this one is some of ground. So this I1 dash equals to V1 minus 0 by 10, so V1 by 10. So we can write it V1 by 10. Okay, so this one is very important, this one. Okay, and how I am doing, just think this concept, simple fundamental concept. So now one can easily write the one equation like, okay, I have to select first pencil. We can write 10 I1 plus V2 minus V1 equals to V1. So one can write 10 I1 equals to, now I'm writing directly 2V1 minus V2. So I1 can be written as 0.2 V1 by dividing by 10 minus 0.1 V2. Okay. So this one is the one important relationship. I1 as a function of I1 as a function of V1 V2. We have written. Okay. So this one is the main equation. So again I am highlighting this one because this one is important. So okay. Now similarly, now at point B, what we have to do? Apply KCL. Okay, I am writing here. Apply KCL at point B. Okay, by applying KCL at point B. So this point is B. Say this point is B, and this current is our I2, and I am saying this one is our I1 double dash. Okay, we have assumed. Okay, and this current is, I am saying I2 dash is going. Okay, I am also highlighting here. This one is our I1 double dash. Okay, and we are assuming that it is I2 dash. So one can easily write the total incoming current at point B. Incoming current I2 equals to total outgoing I1 double dash plus I2 dash. Okay, so now we can write I2 I1 double dash. I1 double dash we have already found. V2 minus V1 by 10. So better to write V2 minus V1 by 10. V2 minus V1 by 10 plus I2 dash. For I2 dash, what we can write? This value will be our V2 is 10 ohm, and this one is ground, and this one is I2. So I2 will be simply our V2 minus 0 by 10. So it is V2 by 10, and this one is our V2 minus, okay, by 10. V2 minus V1 by 10. Okay, so now one can easily write in I2 equation. So this should be our I2 dash. Better to write I2 dash. Sorry. Now this one is our, say this one is equation number one. So equation number two. Okay. And this we can say equation A. Anything you can assume. Okay. So now what we can write? I2. I2 can be written as I1 double dash. Okay. Once again there is notation problem. I1 double dash. It should be I1 double dash, na? So I1 double dash V2 minus V1 by 10. Okay, sorry once again. So I2 equals to I1 double dash. That is our V2 minus V1 by 10 plus V2 by 10. So one can write 10 I2 equals to twice V2 minus V1. Okay, simple calculation is there. Or we can write as 10 I2 equals to minus V1 plus twice V2, or I2 we can better to write by dividing by 10 on both sides 0.1 V1 plus 0.2 V2. Okay, so now we can easily say and say this one is question number B. Anything you can write. Okay, so I1 is there, I2 is there. So once again I am writing I1 is here 0.2 V1 minus 0.1 V2, and I2 equals to minus 0.1 plus 0.2 V2. So this one is nothing but simply I1 I2 with some value 0.1 minus 0.1 0.2, then we have to write V1 V2. Okay, V1 is missing here, V1 V2. So this one is the y parameter matrix, final matrix. So I am highlighting this equation is important. Okay, so y11 y12 y21 y22. So we have to check which one is the correct. 0.2, 0.2 is the diagonal, and 0.1, 0.1 with minus sign. So which one is correct? So option number A is the correct one. So this is the answer. So this is all about the very fundamental concept, but you have to know KVL KCL concept. If you know the basic of KVL KCL, then you can make any question very easily. So this is all about this question. So thank you for watching this video.